to this next lecture 1B. It's about we learn about AI, machine learning, deep learning. It's often time you might be confused. So in this lecture I am going to explain it in a very simple way, that what they are, how they are different and what they typically mean. So what is the difference between AI, artificial intelligence, ML, machine learning, DL, deep learning. Okay. So let's take this system and what is this? Now what we see that before we interpret deep learning models, this course is about interpretable deep learning. Before we interpret deep learning model, we should understand what is AI, what is ML, and DL means, or deep learning means. So you can see the AI is a big father, big father, where it can be used for many kind of places, robotic planning, expert system. So when AI it begin for robotic and planning and building an expert system. Later on, machine learning field evolved, and where it is a subset of AI. What it does, where a machine learning algorithm learns pattern from the input data. So means you don't have to program each and every rules in the system as we were doing in the expert system, but given a data, it can learn the pattern and it can create the rule internally for doing the predictions. Okay. Now this machine learning is an algorithm approach where it was taking input data and labels and feature engineering and everything was there. But then a new field is appear called deep learning. It is a subset of machine learning where internally there are multi-layer neural networks are there, and that neural networks is creating its own feature. It is also learning patterns, but the feature part it's doing in itself, and it can be learned with a very large data. Machine learning algorithm initially can learn, but it was slow and it was taking more time. Now later on, deep learning has been implemented on general purpose unit GPU processors, and it doing. So now AI examples, what you see is, if you have an robotic system, you have a planning system, and you have an expert system, that is an AI. Later on, ML example like detecting spam from the email, the fraud detection of credit card fraud, weather forecasting, these are all ML kind of examples. Then deep learning came up. The human had interest in detecting things, so it practically evolved from a computer vision field. Later on, it applied to speech recognition, and then nowadays generative AI, what you are using it. So DL is more powerful. Deep learning is very powerful, but it is often hard to interpret. AI system was, when it was beginning, we were able to explain the things. ML still was a bit explainable, but as we moved to deep learning, it became less interpretable. So let's move to the definition, or what basically an AI means. So when we say AI is basically a broad field, right? AI is a broad field building the system that can perform the task which typically a human require. For example, to reason something, I am telling you do this mathematical computation 2 plus 2, okay, or may make what is the 5 cross 3, means 5 multiplies by 3. So I am doing reasoning task, right? Then decision making, that I have given you 5 apples, and then there was a 5 apples, and then out of 5 apples 3 apple was being given to 3 student. How many apples left? So a decision making is been done, or deciding between I show you this what it is. So you have to decide what it is. It is a marker pen. So that is called decision making. Perception means perceiving what is in the environment, or perceiving any kind of future perception. Then language understanding. So nowadays the chat GPTs are there, which can understand our language. Then there are Siri, there are Alexa systems are there. Even you have the phone, the remote control at home, most smart TV remote control. You can switch on the audio button and you can command it that open this channel, that channel. That is language understanding. And planning, the long term planning. So this, if we are asking building a system by which we are doing anything like reasoning, decision making, perception, language understanding, planning, or all of them or combination of them, which these are the things typically require human intelligence, and if we are adding this to the machine, that is called AI. Okay. Now it is done. When we go for machine learning, so machine learning field evolved with time. So you give a data to a system and then it is going to find patterns from the data. So what typically it's a learning algorithm. From a given data can be a tabular data, images, it can be text data, it can be sensor data, time series data, and from it is going to find pattern where you ask the algorithm has minimization function, you minimize the error to learn from it. So it learns pattern from the data, and after that, and this pattern is mapped into the model, and then it is going to give prediction. So if it is made to identify cat, so it is going to make prediction like a cat. So it can make decision, or it can estimate, let's say you trained it for stock market, then it is going to tell you what is a future stock value given this was the previous stock prices. So that is estimation. Now here what we are doing, we are not writing each and every rule. Like for example, if you are building a stock market based system, that okay, Google company has this stock pattern, Apple company has this stock pattern, then in future OpenAI comes has this pattern, Nvidia has this pattern. So if we make that kind of rule for each and everything, that was AI system when we were making expert system kind of thing, where we were defining rule for it. But in machine learning, it is learning pattern, and we are not writing every rule. We simply give the data to the system and it learns pattern. For example, if you show fruits, right, then if I give you a citrus fruit, like you have orange, lemon and mango, right. Now if I give you a citrus fruit, orange, lemon and mango, or mandarin, let's say orange, lemon and mandarin, then as a human we will be able to separate this is orange, lemon, this is mango. So we had learned the pattern, what orange look like, what lemon look like, what mango look, mandarin look like. So now machine learning will also learn that kind of data from given a data pattern from the data, and it can tell. So in previously before machine learning came up, we were creating rules and we were fitting into the data to get the output. Now we are giving the data to the machine, and machine is learning the pattern from the data and giving the prediction. So that is where the machine learning is different, or it is a subset of AI system. So any machine learning is AI, but not all AI is machine learning. Okay. Now how the machine learning works. In the machine learning there are three parts are there. Okay. First is how decision process, like given an input data. So this is a machine learning thing. There are decision process, error function and optimization. So given an input data, it is asked to produce prediction or decision. Means prediction means regression, decision means classification. So system is, we can classify into two kind of tasks, classify or regress, so which is prediction, right. Now how it does, for example, email came, whether this email is spam or not, the ask is to detect spam or not, classify. So it is going to when you are training the algorithm, you are giving the data, so data also have the labels to it, that this particular email belong to the spam class, this email is not belong to the spam class, right? Or if I am building a cat and dog identification system, so this image is of cat and this image is of dog. Then it is going to, if you are giving the system first one image of cat and it will try to learn it, initially it will have an error. So now this error is going to be, the machine is going to be asked to reduce the error, and that is the by optimizing it. So the error is going to be given back that this much error we have, and it is going to correct for the next cat image is given, it is going to reduce the error, and that's how it is going to learn. For this email spam case, it is going to learn based on the initially the error is going to be high for email which belong to the spam, but then as the optimization is there, the model is going to adjust to reduce the error for future prediction, then model is going to learn over the time. So basically you give a input data, the system is going to predict, and then it is going to compare with the ground truth, and after that if error is high, it is going to update the model so that next time a new input data comes, it is again going to predict, and it is going to compare with the ground truth, and that time the error value will be expected to be lower than the previous one. And when this process is repeated multiple times, and over the time the error is going to be so low that you can say that model is trained, and after that you can put a system to work into the commercial phase or deployment, and that time it can make the decision to make prediction. And when it is deployed, that time it is not optimizing it. This is for the training purpose. Okay. Now where does the deep learning differs? Now machine learning can be done on anything, any kind of input data, and within the machine learning it had the limitation that we were having difficulty working with large data, means too much data. For example, I remember when I was doing a PhD, 2008-2009, and that time machine learning was famous, right? Machine learning was famous, if you cannot see. Okay. Now machine learning was famous. In that time I was also doing a PhD in AI, and my task was to detect an object, right? Means given a robot, I was making robot which can identify anything in the house, basically making a robot suitable for creating a household helper. It can identify anything in the home environment or natural environment, like it can detect this pen, it can identify my jacket, it can also tell who I am, it can also detect the mic here, it can detect I am wearing a pant, and many kind of thing. Okay. So, and take a cup and plate. Now in that time the deep learning was not there, machine learning was there, and we were working with random forest and decision tree and then support vector machine, this kind of technology or techniques for doing the machine learning, and various kind of optimization process were there. Now that time we were working, if we had a there was a data set called Caltech 101 where 101 classes are there. Later on Caltech 256 data set came where 256 classes were there and certain images were there. So task was to identify the classes. Now this time the machine learning algorithm which win the best paper award at a very big conference called CVPR in 2010, and that algorithm which machine learning which learned and had a higher accuracy for the market, and it took almost 28 days to learn. 28 days. Now so that's how the slow machine learning was for Caltech 256. Nowadays if you put this Caltech 256 into the deep learning model, it can be trained within 10 minutes or 15 minutes in the modern GPU system. So that's where this deep learning became advantage. So deep learning is basically what it is. Same image, text, audio, tabular data goes. One advantage deep learning gave, that you do not have to do the feature engineering. In some lectures I will do what feature engineering is. If you take my data exploratory or exploratory data analysis or exploratory AI, if you take the course, that you can find feature engineering focused thing. So in this, what you simply pass the data and what is the ground truth, and then internally it creates a feature also. So, and the difference between a normal machine learning and deep learning is that it has a multi-layer neural network. So deep learning, so it is basically deep neural network learning, DNN, or that time in this you have multi-layer neural network which is has many hidden layers, and it is learning the complex pattern and is making that internally the representation is there, but this explanation was in terms of machine, not as a human understanding way. Okay, and it can be done for detecting class prediction. It can also do audio detection, speech recognition. It can also do content, generate content like image, etc. So deep learning automatically learns useful features. So feature was, so before deep learning came, people who were working in machine learning, they were often, if they are doing PhD, their most of the PhD was actually coming up with a feature which can do better machine learning thing. But once deep learning came, this feature engineering task went off because deep learning learns feature automatically, and you can use large amount of data. Means nowadays the systems are there that you just put a robot and it will start learning what is there in this meeting room, how many chairs are there, how many desks are there, what is kept where, and how to organize everything. It will be able to do it. So that's how the deep learning given an advantage. So you learn that. So I can tell you that every AI system is a machine learning, but every machine learning is not AI. Similarly, every machine learning is a deep learning, and not every deep learning is machine learning. Now every AI system is a deep learning system, means every deep learning system is an AI system, but not every AI system is a deep learning system. So now to summarize it in a simple way, so AI is a godfather, great grandfather, machine learning is a father, and deep learning is a son. And within the deep learning there are more other separation has came up like generative AI and all. So that is grandson and other thing. So going forward, now question comes, why deep learning is so powerful. So what made deep learning so powerful is that, I was telling you that when I was doing PhD in 2008 and 9, and that time I was in first, second year of my PhD, that time the data was even a Caltech 256 data. Later on ImageNet came up where 10,000 classes were there. So when the 10,000 classes were there, training on ImageNet can take years. Okay. But then the deep learning came. Now without adding a data machine learning system or a modern AI system cannot be made powerful. Before we were working with 6 classes, identify between walking, jumping, sitting, and not moving. This is a very simple rudimentary task. Back in 2000, 2010, people were busy only identifying 6 classes. Now we can do millions of identification, action, etc. So that is possible because we are having large data set. Now the learning was slow with a traditional machine learning system and only using the CPU. Now CPU, even you have a 8-core system or 16-core system, only 16 processes you can do at a time. But then the GPUs came up, okay, graphical processing unit came up, and in the GPU you have cores, many small cores are there, and Lect1B and his team, Jan Lect1B and his team, first given a model called AlexNet, which was been programmed or which has been framework to run on a GPU system of NVIDIA. And since in GPU you have a 1000 cores, or nowadays 4000 cores are there, so you can understand that 4000 times increase in training you have made it. And deep learning also has a task which require a small computation. Many millions of tasks is needed, but very small computation. So neural network architecture was been able to run on the GPU, and then the advancement in computer vision and natural language processing, it is able to work. And then the big push came from transformer. So what you see, ChatGPT is working great because the transformer came into the picture, and later on generative AI came, like generative adversarial network, and later on diffusion model, etc. So that made this deep learning so powerful, is able to do so many tasks, and that's what you see all this hype on AI about. But so you see what typically deep learning is there. You give a data, internally this data will be passed. There are many hidden layers are there, neural networks are there. Internally it is learning. In the beginning it has a low level feature like edge, colors. Then it learning internally like ear, eye, nose, etc. Then high level features are there, uh, like full face or something. But all this is an abstract representation concept, and finally it is making a decision of something. So it learns things automatically and capture complex pattern, even human misses, and it has a very high performance. Nowadays this AI systems based on deep learning are getting used for immigration purpose. Like if you go to Singapore, immigrating from Singapore is just a 7-second task. You just appear, camera identifies you, and it let you pass. 7 seconds, you get double verified with 2 different system, and you finish the immigration. But if you have been into immigration, and you know the Singapore has millions of passengers coming from all over the world, and they are using it. Even in the Dubai, they are using this immigration system for face detection, and you know those are very, and these are all based on deep learning, and then whole AI systems are there on it. Now deep learning is very powerful, but it became difficult to explain. Means deep learning is very difficult to explain. Many problem is there, you know, there are many layers, you know. Nowadays, for example, the AlexNet was there, that was 16 layer, or VGG 16 was there. There are 16 layer, then VGG 19 came up, 19 layers. And even if you take AlexNet or VGG 16 and 19, they have around 100 million parameters, more than 100 million parameters are there. And parameters means these are all different nodes are there, neural networks are there, and the connection to these nodes have some kind of value, and those are called parameters. Now that many millions of connections are there, how will you find out what is working and which is learning, which is not learning? So having too many layers, decision passed through many hidden layers, and there are millions of parameters, and many non-linear operations are there. So non-linear operation means if I say if there is analytical logic are there, 2 plus 2 is equal to 4, that is called linear operation. If I am doing y equal to, means if I am using a parabolic equation square function, and I am doing any kind of random clipping, etc., that more than 80% I remove it, or I am allowing more than 80% to pass. So those are called non-linear operation, which we cannot reverse it. So many non-linear operations are there in the deep learning, and non-linear operations are there in the deep learning that makes deep learning learn faster and do a many good job, but that also makes it non-interpretable. So, and then there are many hidden features are there, and there are representations are across all over the place. It's very difficult to find out what it is learning and how it is predicting. So that making deep learning very difficult to interpret. In this course we will learn few of the things how to make deep learning more interpretable and more explainable. So, and deep learning can work with any kind of data, image data, text data, audio data, tabular data, you name any kind of data it can work with. So we will learn in this course how to make it. Now in this next, you have to think yourself, do you need more accurate model? Means do you think accurate models are always better model? So with this thought, I will take you to the next lecture. In the next lecture, we will know about AI history in briefly, and how the history of AI will make so that why we reach to this black box problem of non-interpretable system. So we will learn from this history. Okay. So I hope you learned something about the representation between AI and difference between AI, machine learning, deep learning, and follow me for the next lecture, brief history of AI, and you will enjoy it. Thank you.